Now here was the third constraint, if you like, imposed on the GNFA to make it more useful. And Sipser, he has a special term for this modified GNFA that meets these three constraints. He calls such a GNFA special form. Yeah, right. A special form GNFA. The GNFA that has these three constraints imposed on it. Okay. Now, how to convert? Now, remember from previous session, you start with your DFA, which is the DFA that recognizes the language. Remember, we're talking about a regular language, right? By definition, a regular language has a DFA that recognizes it. So you have a given language, therefore you have the DFA that recognizes it. And now, how to convert a DFA into a GNFA. And Sipser claims that's fairly easy. Haven't done it yet, but so we're going to convert a DFA. Now remember that that two-step process. You go from a DFA into a GNFA, and then from the GNFA you can generate the regular expression. Okay, so if you skip the middle process, the GNFA, in other words, you're going from the DFA to the regular expression. Okay. So, but what we're going to talk about now is how do you convert a DFA into its corresponding GNFA? Right? How do you do that step? And he says it's pretty simple, and there's no diagram to show how it's done, just with words. So I didn't bother drawing one either. Imagine now my fist is the DFA that you have. Okay, meaning the state diagram, state transition diagram of that DFA. Now you create to generate a GNFA from that DFA. Create a new state, a start state. Okay, and draw an epsilon arrow, transition arrow from that start state, that new start state, to the start state of the DFA. Right? So new start state, transition arrow with an epsilon label, okay, and that arrow goes to the start state of the DFA. Right? Now imagine this fist is the DFA with the new start state, let's say here where I'm wiggling. Now here create one accept state. Remember, it's a GNFA, it only has one accept state, okay? And have from the accept states of your DFA, have transition arrows from the DFA to this one accept state. That one accept state from that would be your one accept state in GNFA. Right? Now the transition arrows from those accept states in the DFA, my fist, okay, those transition arrows, label them all with epsilons, okay, and they all go to the single accept state of your GNFA. Okay, and that's sort of what it's saying here. Now there are a few complications. For example, say some of your arrows have multiple labels. They have more than one label on it. Well, if that happens, replace them with a single arrow, but the label is the union of the previous labels. I hope that's clear. Now you may, there's a kind of recipe given to you here. You may be asking, well, where did all this come from, and why? Well, you just need to get more experience with it, and I assume with the 65 questions at the end of chapter 1, some of them, when I look, just check this cute, like how many questions deal with GNFAs. See if I can just do it quickly. Pumping lemma, that's the right next section. Pumping. So see if I can just see the GNFA. Not so far. Not so far. Oh, I'm looking at the selected solutions. No, I don't see any so far. No, don't see them. That's not to say they aren't there, but they're not evident. Okay. Alright, and a few other little things you need to do to convert your DFA to a GNFA. Now, if you have states in your DFA that have no arrow, so if you have, right. Now remember, in a GNFA, every non-start and non-accept state has to have arrows going between them. So for all of those non-start accept states, they're fully connected in a sense. Like each one sends an arrow to every other one, and every one sends arrow to all the others. So each one will have, given any two of those non-start accept states, there will be an arrow to it and from it. Okay. Now, if in your DFA you have no, if you have no arrows between those two states, well, add an arrow but label it the empty set. Right? And you may ask why. Well, think about it. Okay. Now, doing this, it won't change the language detected at all, because there's no